Notebook page 31, going over the physical property of density. So density is the substance's unique mass to volume ratio. So density simply represents the number of particles needed to occupy exactly 1 milliliter of space. Now, we can't sit there and individually count out the number of particles. It would be too time consuming, and the particles are too small for us to see the individuals. So the way we count the number of particles in lab class is that we actually measure the mass. So we measure the mass to determine the number of particles, and occupying space is simply the quantity of volume that we measure out in class. So density represents the number of particles that occupy 1 milliliter of space. So let's take a look at these three pictures down below. So each picture, each box represents 1 milliliter of space. But when you look from the gas sample towards the liquid sample to the solid sample, we move from less dense to more dense. And the reason is that we see that as we move from solid to liquid, or gas to liquid to solid, it becomes more dense because there are more particles stuffed into that 1 milliliter of space. And the more particles we pack into that specified amount of space, we see an increase in the mass value. Now density, it can be expressed in a couple of different units. So one common unit is gram per milliliter, and we'll typically use milliliter if the volume was measured using a graduated cylinder. Another common unit for density is grams per centimeters cubed. So a ruler was probably used to measure length, width, and height, and the volume was calculated from it. Now, here's one thing that you need to commit to memory. It's not in your reference tables, but you're expected to know it, is that 1 milliliter of space occupies the exact same amount of space as 1 centimeter cubed. So 1 milliliter equates to 1 centimeter cubed. Now, if I asked you for the density of water, okay, so if I asked you for the density of water, many of you right away would say the density of water is 1.0 grams per milliliter. But the crazy thing is we use that value all the time, but this density value, 1 gram per milliliter, is actually only true when the water's temperature is being held at 4 degrees Celsius. So the density value of a substance is only true at a specific temperature. So if you look up the density of water, you will find that at common room temperature somewhere, 20 degrees Celsius, 21 degrees Celsius, which would be room temperature 25 degrees Celsius in that area, water's density value is actually 0.9 something, less than 1. Now, the next big idea is, how do we use density information? Okay, so the density value is a relationship. So we're talking about changing from one unit of expression or one quantity to another. Density is very useful. It allows us to convert between the mass and volume of a substance. So for instance, if you looked up the density value of aluminum, the density of aluminum equals 2.69 grams per milliliter. We say that, but do we really understand it? So let's write a sentence that explains this summary right here. So in science class, we like to use summary ideas, but we have to also understand, what does that little summary represent? So this is what it means. Every 2.69 grams of aluminum will occupy 1.0 milliliters of space. So every 2.69 grams of aluminum will occupy 1.0 milliliters of space. That mass to volume ratio is unique for each substance. So if we want to convert, if we measure out the mass of aluminum sample, we want to convert it to the amount of space it occupies, or we have done water displacement or used a ruler and we have determined the volume of the aluminum sample and we want to convert it to the mass of the sample and we don't have a digital balance available, we can use this relationship. There are two equivalences. So equivalence one would be the normal, would be the grams to milliliters. So every 2.69 grams of aluminum will occupy that 1 milliliter. Or we could use equivalence 2 that is just as true. We can go from milliliters to grams. 1 milliliter of aluminum will mass out to 2.69 grams. So it's the same equivalence. It's just which quantity are we starting in and what are we converting it to.